Have you ever wondered how humanity will explore the universe in the future? As we stand on the precipice of the unknown, our current technology often seems woefully inadequate for the task. Our conventional rockets, though powerful, are limited by the sheer amount of fuel they can carry. And the vast distances of space make travel times prohibitive, even at the speed of light. Yet, as we gaze upon the stars, we can't help but dream of a future where we can traverse the cosmos with ease. A future where the boundaries of our exploration are not dictated by the limitations of our technology, but by the breadth of our curiosity and the boldness of our spirit. So, we ponder and ask, is there a different, more efficient way to conquer the space? Can we harness the very elements of the cosmos to propel us into the future? We're on the cusp of a revolutionary leap in space travel, a method of propulsion that could change the way we explore the universe forever. What if we told you that the answer might be blowing in the wind, or more accurately, the solar wind? Enter the concept of solar sails, a method of propulsion that relies not on fuel but on light. Imagine a sailboat gliding effortlessly on the sea, propelled forward by the wind. Now picture the same concept, but in the vast expanse of space. Instead of wind, it's the pressure of light particles, or photons, emitted by the sun, that propels the spacecraft forward. This is the fundamental principle behind solar sails. The concept of solar sails isn't exactly new. The idea has been around since the late 19th century, when it was first proposed by the Russian space scientist Konstantin Tsiolkovsky. Inspired by the possibility of harnessing the power of light for propulsion, he dreamt of spacecraft navigating the cosmos much like ships traversing the sea. However, it wasn't until the late 20th century that the idea began to take form. In the early 1970s, NASA began exploring the feasibility of solar sails, leading to numerous research projects and experimental spacecraft. The progression of solar sails over the years has been marked by a series of trials, triumphs, and tribulations. Early prototypes struggled to cope with the harsh conditions of space and the subtleties of light propulsion. Then in the early 21st century, the first successful deployment of a solar sail took place. A Japanese spacecraft named Icaros, short for Interplanetary Kitecraft Accelerated by Radiation of the Sun, was launched into space. With a sail made of ultra-thin material, it began its journey, slowly but surely propelled by the pressure of sunlight. Today, solar sail technology continues to evolve. Each new generation of sails is lighter, more efficient, and more durable than the last. The dream of interstellar travel, once confined to the realms of science fiction, is now within our reach. So you see, solar sails could very well be the wind in our sails, the key to unlocking interstellar travel. But how exactly do these solar sails work, you may wonder? Well, the magic lies in the science of light. You see, light is made up of particles known as photons. Though they lack mass, these photons carry momentum. When a stream of these light particles or photons hits a surface, they bounce off, exerting a small pressure known as radiation pressure. This is a subtle but relentless force, much like a gentle breeze that never stops blowing. Now imagine a vast, thin, mirror-like sheet suspended in space. When sunlight falls on this sheet, photons bounce off it, exerting their radiation pressure. The cumulative effect of billions upon billions of these tiny photon impacts provides a continuous push. This is the principle that propels a solar sail. But what is this sail made of? The material needs to be lightweight yet durable and highly reflective. The most commonly used material is a thin sheet of mylar, a type of polyester film. This is often coated with a layer of aluminium to enhance its reflectivity. These sails can be incredibly thin, some just a few hundredths of a millimeter, which helps to maximize their surface area to mass ratio. The sails are unfurled in space, catching the wind of sunlight and using it to gradually accelerate. Unlike a rocket that burns all its fuel in a short time, a solar sail can keep on accelerating as long as there's sunlight. It's a slow start, but given enough time, a solar sail can reach substantial speeds, and thus, by harnessing the ceaseless energy of the sun, we can create a form of propulsion that needs no fuel, has no moving parts, and can theoretically operate indefinitely. With this seemingly simple concept, we might be able to sail the stars. Every innovation brings with it a set of advantages and challenges. Solar sails, the ingenious invention for space exploration, are no exception. Let's delve into the duality of this cutting-edge technology, starting with the upshots. The first and perhaps the most captivating advantage of solar sails is their fuel efficiency. Traditional spacecrafts rely on chemical propulsion, which, although powerful, is limited by the amount of fuel a vessel can carry. Once the fuel runs out, the voyage ends. However, solar sails harness the power of the sun, using its photons to generate a gentle but constant push. This means that as long as the sun shines, the solar sail can continue its journey, making it a truly renewable means of space travel. This leads us to the second advantage, the potential for long-distance interstellar travel. Given the constant propulsion, a solar sail could theoretically keep accelerating over a long period, reaching speeds that conventional spacecrafts can only dream of. This opens up tantalizing possibilities for exploration beyond our solar system and perhaps even to the nearest stars. But as with all innovations, solar sails are not without their challenges. One of the major hurdles is the difficulty of controlling their direction. Solar sails are pushed by the sun's photons, which means they are always moving away from the sun. This makes it tough to navigate a solar sail in any direction other than straight outwards from the sun. Moreover, the size of the sails required is another challenge. To capture enough sunlight for propulsion, solar sails need to be extremely large, often many kilometers in diameter. Designing, manufacturing, and deploying such gigantic structures in space is an engineering challenge of mammoth proportions. There's also the matter of durability. The harsh conditions in space, including cosmic rays and micrometeoroids, can damage the delicate sails, affecting their performance and lifespan. Despite these challenges, the potential rewards of solar sails are too vast to ignore. As technology advances, we may find ways to overcome these hurdles, turning the dream of interstellar travel into a reality. After all, we are a species driven by curiosity and innovation, and the universe is a playground that we've only just begun to explore. Solar sails are more than just a concept. They are already being put to the test. To truly understand the potential of these cosmic voyages, we need to delve into some of the missions that have utilized or are preparing to use solar sails. Let's embark on a journey to the land of the rising sun, Japan, where the Icaros project was born. The interplanetary kitecraft accelerated by radiation of the sun, or Icaros, is a testament to the practical application of solar sails. Launched in May 2010, it was the first spacecraft to successfully demonstrate solar sail technology in interplanetary space. Harnessing the power of sunlight, Icaros journeyed towards Venus, proving that solar sails could indeed propel a spacecraft. Now let's travel halfway across the world to the United States, where another significant mission has been making waves in the realm of solar sails. The LightSail 2 mission, an initiative by the Planetary Society, took to the stars in June 2019. This cube-shaped spacecraft, the size of a loaf of bread, is powered by a solar sail that's just 4.5 microns thick. That's less than 1/10 the thickness of a human hair. Yet this delicate film of mylar has been capturing sunlight and transferring its momentum, allowing LightSail 2 to change its orbit around Earth. These missions are more than just successful experiments. They are precursors to a new era of space exploration. They demonstrate how the simple yet profound principle of solar sailing can be harnessed to travel the cosmos. These missions are proving that solar sails are not just a dream, but a viable method of space exploration. The future of solar sails looks bright, quite literally. As we stand on the cusp of a new era in space exploration, solar sails promise to be a beacon of hope, guiding us to the farthest corners of the universe. Imagine for a moment the possibilities. Interstellar travel, a concept that has long been confined to the realm of science fiction, could become a reality. With the light of the sun as their fuel, solar sails could carry us beyond the limits of our solar system, to distant stars and unknown planets. This isn't just idle speculation. Scientists and engineers are already hard at work refining the technology and finding new ways to harness the power of the sun. Future solar sails could be larger, lighter, and more efficient, capable of reaching speeds that are currently unimaginable. But it's not just about speed. Solar sails could also be used for precision navigation, allowing us to explore celestial bodies with unprecedented accuracy. Imagine a future where we could send a solar sail spacecraft to investigate an asteroid, a comet, or even a distant planet, and then bring it back to Earth for study. Of course, there are still many challenges to overcome. The technology is still in its infancy and there's much we don't know. But every journey begins with a single step, or in this case, a single photon. Every day we're learning more about how to harness the power of the sun, how to build better solar sails, and how to navigate the vast expanse of space. It's a grand adventure, and we're just getting started. As we continue to push the boundaries of what's possible, who knows where solar sails might take us? The future is a vast, uncharted sea, and we're setting sail into the unknown. With the power of the sun and the promise of solar sails, there's no limit to where we might go. As we continue to push the boundaries of what's possible, who knows where solar sails might take us?